Okay, robot formula or robot integration uses trapezoidal rule to give preliminary approximation, then applies the Richardson extrapolation process to improve the approximation. Okay, if we divide it to 2, if you remember, if you see the I 1, 2, 3, then for the iteration 1, calculate R11, H2, R21, R22, R31, sorry, 31, it will be R32, R33, and R41, R42, R43, R44, and so on. Okay, 5, so on. Okay, divided by 2 in robot integration. For the first one here, this column, we will use trapezoidal rule, okay, for each of the R11, 21, 31, and 41. But for the rest here, we will use Richardson extrapolation, okay, Richardson improvement to calculate. So we have two different formula, R11 all with 1 at the end, 11, 21, 31, 41, we will use trapezoidal rule. But for the next here, the rest 2, 2, 3, 2, 3, 3, 4, 2, 4, 3, 4, 4 here, all will use Richardson approximation. Okay, the first step in robot integration is very crucial. Okay, because if you make this calculation wrong, all the other calculation will be wrong. Okay. For example, here we start with the first step in robot process obtains the trapezoidal rule. So we know already, usually in chapter 10 here, we will have A and B will be given to you, and your H1 is a difference between A and B, your H. Okay, and to find your R11, this is the first calculation. We always start with R11. Okay, to find R11, this is the formula, the trapezoid formula that will be used. Okay, and in the next one, if you want to find R22, R31, R41, it will use the previous calculation. Let's say next one R21, right? You want to find R21. You will know that you will need to use R11 later. I will show you the example after this. And then for the next NI, let's say this is the first one, the first interval, okay, you will have A and B. This is the trapezoidal rule. If you remember, we have A and B point, right? So this is your F x0, is your Fx1. Okay, this is x0 and x1. You can say this x0 and x1. So your F0 will be at point A or x0, and your F1 will be here at point x1. But for the next subinterval, let's say n2 is equals to 2 minus 1 power of 1. So n2, we have subinterval 2. So subinterval 2 means that you will have two subinterval now. Before this only one subinterval, n1. Now n2, you will have two subinterval where this is your A, this is your x1, this is your B. So this is actually your x0, x1, and x2. And if you look at the formula, it will be different to calculate the x2, the n interval. Let's say for R21 here, right? So half R, your I is 2, 2 minus 1, 1, R11. So you will use the previous calculation here for the second one, plus HI minus 1 is I is 2, so H1 you already calculate here before, and summation of, okay, K equals to 1, and this is 2I minus 2, which is 2 minus 2 is 0, which is 1, right? So F2 K is only 1, so 2 minus 1, F1. only F1, H1, F1. So for, let's say for R21, formula is R11 plus H1, already calculated here, and F1. But F1 for the second subinterval, this is your F0, this is your F1, okay, this is your F2. So if you see the F1, Fx1 here is on the point B, but the next one is not in the point B, it's point x1 here in the middle. Okay, it is not at the same point. Let's say your h is 4, right? This is 0, this is 4. So the fx1 for R11 is 4. But the fx1 for this one is not 4. So let's say we use the calculation, right? h2, 4 minus 0, 2 power of 2 power of 1, which is 2, right? 4 divided by 2 is equals to 2. So your h now is 2, 2. So this is 0, this is 2, this is 4. So your fx1 is 2. This is different from this one. This one is fx1 is 4. Right? So I highly suggest you draw this type of drawing in your calculation for easier understanding of where is your fx. Okay. Okay, this is the same like I did previously. The I is 2. So N2 is N2, and then as I draw before, now we have 3. This is your A, this is your X1, this is your B. So this is your X0, X2. Okay, so this is your F0, F1, and F2. If you see the calculation, this is the formula to be used to find your R21. So you need half, you need R11 that you calculated previously, H1 also you calculated previously, and yeah, F1 is on this. Yeah, this is the value for your fx1. Okay, so it's different. As I mentioned before this your x1 is on the dot B before for the R11. Okay, if you make mistake for your R11, R21, the next calculation will be wrong because it always use it for your next one. Remember R21 here, they will use your R11. For your R22, they will use your R21. Okay, so it is important for you to really understand how to find the F1 and how to calculate correctly your R11, R21. Okay, and your H for the new one, use either this equation to find your new H. Okay, you already have your B and your A divided by how many i's. Your I is 2, you put 2 here, and then you put 2 here, put your B and A, you can find your H. Same as here, same thing, you can put your 2 here, 2 here, and then you can find your H. Okay, this is the example for I equals to 3. Before this, I1, I2, now I is 3. If you see I is 3, so and 3, 2 power 3 minus 1 is 2, right? 2 power 2 is 4. So now we have 4n. This is your A, this is your B, x1, x2, x3. Okay, we have 4 interval. 1, 2, 3, 4. This is your x0, this is your x4. Okay, so if you look closely at this equation, you need to use this formula here. So where you need to use your R21, this to find your R31. Okay, in previous calculation, so if you get R21 wrong, your answer here will be wrong. H2 also is based from the previous calculation, the I equals to 2, F1 plus F3. Now look, if you draw this, you can directly see, okay, this is your X1, okay, this is the value of your F1 here. X3, this is your F3. Whatever value here, you put into the equation. Okay, that's the important thing about this drawing. Alright, and then you can also find another, this example until R31. You can also find R41, R51 by using this formula. Just put it here, 4, 5, 4, 5, 4, 5, either 4, either 5 or 6, how many numbers that you want to calculate, you can find using this formula. Okay, and then your age also is the same. If you want to find age 4, age 5, age 6, just put into the equation 4, 5, 6, then you can find your answer for your age, right? Okay, before this, all the calculation is about the trapezoidal rule, okay, where you want to count for R11, R21, R31, R41, and so on, with 1 at the end. But everything else on this side, which is R22, you have R32, R33, and so on, 4, 2, 4, 3, 5, everything, you will use this formula. Okay, just insert these two here into the formula. Let's say you want to find R52, put into the formula, and you can find directly. This is J, so this is 2, I is 5, this is 2, this is 2, this is 5, this is 2. Okay, do the calculation here, you will get your formula for R52. How to find the formula for R52? Okay, by inserting the I and the J's inside the formula. Okay, but for now, the most popular one usually that you need to count is this one, R22. Of course, you have this one, and this one is quite popular to be counted because, as you know, this is a numerical method. You need to find until the error usually, or until the exact point. So usually you need to do almost 2-3 iteration. So this is the most popular one, right? They already give it to you. You can find this 2 inside here if you want. You can put 2 here, and then you do yourself. You got the same formula. Okay, now they already give to you, you just use it. This is formula for Richardson improvement for R22, R32, 33, and 44. Okay, let's look at an example here. Let's say we have your I1. Okay, imagine you have your I. So this is the first I, number 1. And you need to count R11. This is the first level. Okay, 2, we have R22. No, sorry. You will have R21 first. R21, and then your R22. 21, R22. And then the third I, R31, R32, R33. The fourth, next one, 41, 42, 43, 44. Okay. So for first I, this is the formula that you need to use, the trapezoidal rule, because this is, remember, it ends with 1. So we divide by 2. This is the trapezoidal rule. This is the Richardson improvement. Okay. So trapezoidal rule for R11, and you find your first age is by minus B, and A. B minus A, you get your first age. Okay. So for F0, this is your F0, and this is your F1. Look at I2. Here we have 2 need to count. Okay, one trapezoidal rule, one based by the Richardson improvement. So this is the formula. Okay, you need to use the R11, which you already calculated before. Your H1, you already find it here, and your F1. So you need to draw. Remember, I2 means that the interval is 2. Okay, so 2 interval. How you find the interval? You can use these 2 equation here. Either one. You can put H2 and find your interval. So 2 minus 1 is 2 power of 1. Okay, and then B minus A up to the numbers here, and then you can find your H2. Alright, so to find your F1, draw this equation here, where draw this drawing where you have 2n. Okay, so this is your F0, this is your F1, this is your F2. So this is your new F1 for this one. Remember, before this is your F1 for R11. R11, this is your F1 at B. But for R21, this is your X1, which is not B. B is here. But this is a new one for your I2. For R22, we are in this territory, Richardson. So we need to use Richardson improvement. Here they already give to you the R22 formula. Just put inside here where you need to use the calculation that you've done before and the one before that, R11, into the equation, the formula. R33, alright, we will have n is 4. Okay, so 4n, so we have 1, 2, 3, 4, 4n. So we have 5 points, x0, x1, x2, x3, and x4. So what is the formula here? You need to use your R21. This is the formula to find your R31. Okay, you need to find your R21. You already calculated before. Your H2 you also have calculated before, and your F1 and F3. So you draw this. How to find your H3 again? Use the equation. Okay, you can find your H3. You put your 3 here inside here. 3. You put your 3. Either one, up to you where you want, what you want to use. Okay, so you find your H3. You can then draw your x1, x2, and x3. Okay, so this is your F1 and this is your F3. So the value here insert into the equation for F1, the value here insert into the equation for F3. For R32 and R33, we are using, if you remember from the previous slide, I already draw, this is the Richardson improvement. So they already give you the formula, just use it. Okay, use the previous calculation you already done and you put into the equation. I equals to 4. I equals 4, n is 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 n's. Okay, and to find h4 again, use this, put into here h4, so 2 power of 3, and then you divide it by b minus a, so you will get your h. Alright, so this is the calculation for I4. Alright, so you need to use the R31 you calculated in previous slide, H3 also from the previous slide, and F1, F3, F5, and F7. So look at the X here. This is your F1, this is your F3, this is your F5, and this is your F7. Okay, you put the value of X1, X3, X5, and X7 into the equation. Okay, that will be provided to you. Here they don't provide you with the equation for Richardson improvement R42, 43, 44, but you can always put inside here. Let's say this is, you want to find 43, right? Put 43, and then just put here your J is 3, your I is 4, this is 3, this is 4, this is 3, this is 3. Then you will get your formula for R43. Do the same for 42 and 44. You will get your formula for each of them. And at the end, when you answer, I need you to do the table, the rhombus table here, where you can clearly see this is your I1, you will have your R11. This is your I2, you will have your R21 and 22, I3, R31, 32, and 33. If you have I4, okay, we have here R41, R42, R43, R44. This is your H4, and so on. Okay, you need to do this table, all right, at the end of your answer, and then you can compute the rhombus table until it is satisfying your error, less than your error. Okay, let's say if you see I is the same, so it is between the level 3, 3, 3, 4, 4, 4, not this one and the previous one. Okay, so let's see, if you want to find you want to stop, you must, if you find already R2, you can minus R1, see whether it is less than the error. If you not, continue with 3.1, and then if you calculate 3.2, again you minus, see less than error or not. If not, continue for R33, you find your R33, you minus, see whether it is less or not. If still no, continue R41 and find the R42. After you find R42, and then you can minus, see whether it is less or not. If it less, you can stop, and this will be your answer, the value for R42. For example, this is the example, okay? Not exactly you need to stop at 42. No, this is the example. It depends on the error, whether it is satisfying or not. It can be at any points. Let's say R32 minus R31 already satisfied, or R33 already satisfied. It's based from the question. Okay, now we look at the approximation, the example. Okay, use Romberg integration to approximate this fx and compute the Romberg table until this minus is less than 0.0005. Okay, this is your error. Must be less than this, then you can stop. So based from this, you know that your A is equals to 1, your B is equals to 4, and your fx is equals to x plus 4. Okay, based from this question, you should know this already if you look at this question. Okay, now the first thing we need to do is we need to find R11. Okay, how to find R11? We use our trapezoidal rule. So you know, for n1, I equals to 1. So our n is also 1, right? Okay, then you see you find your h by finding your b minus a. You can find your h. 4 minus 1, which is 3. Okay, your h1 is 3. Then your f0 and f1, if you draw this, okay, I suggest you draw this, and this is your f0 and f1. So you want to find f0 and f1. This is the value 1 and 4 for each of them. So you put into the equation, the fx. Okay, your f0 is 1 and f1 is 4. And when you get your answer, you put it here for your f0 and f1, and then you will get the answer for your r11. Now r22i equals to 2. Your n is also 2. Okay, so r21. To find r21, this is the formula. Okay, now you need to find your h. How to find your h? Again, you can use the formula that have been showed to you before. Okay, when you find your h2, it's equals to 1.5 actually. 4 minus 1, the a and the b, right? This is your b, this is your a, minus 2 power of 2 minus 1, which is 1, right? So 4 minus 1 is 3. 3 divided by 2 is 1 over 5. So 1 over 5 plus 1 is 2 over 5 in the middle. Okay, this is your h2. Where you get this calculation, look back at the previous slides. Okay, we have two types, either this one or another one, where half multiplied by your previous h. Okay, you can use either one. So when you draw your I2 here, the drawing, okay, you will see it, this is your I, this is your x0, and this is your, not x1, x2 now. The x1 is the middle, so x0, x1, and x2, this is your 2n, okay, x0, x1, and x2. So this is the value of your x1, which is 2.5. It is not 4 anymore. So if you use this equation, R11 is from the previous calculation, H1 also is from the previous calculation, F1 refer back to the drawing that you make, and then you can see this is your X1, so this is your F1, 2.5. So you put into the equation 2.5, and then you insert into the equation here to find your answer for F2.5. Okay, this is from the R11. Then you will get the answer for your R22. Okay, R21 previously, sorry. Previously I said R21, not R22. Now we want to find R22. Okay, R22, as you know, we do not use the trapezoidal, we will use the Richardson. And you can see this is the equation. So R21 that we calculated previously, in the previous slide, okay, and the R11 we calculate earlier, the first one, right? You use the value that we find, and we can find your R22. Okay, this is the value. So after we find R22, if you remember, this is R11, this is R21. Okay, we find already the value R21, R22, so we can minus them to see the difference. Okay, R22 minus R21. If you remember, after this we will, if it is not satisfied like this, not satisfied, right? So if you minus, it is still bigger. So you need to find R31, and then you need to find R32 first. Then you can minus. If still bigger, R33. Find R33 and then you can minus R32. If still bigger, R41. And then find R42 first. Then we can minus. See whether it is bigger or not. Okay. For R31, we will go back to the trapezoidal rule. And this is the formula for R31. Okay. And it uses the R21 that we already count before, the H2 and F1 and F3. So to find your F1 and F3, find your H3 first. Use the equation I stated before, and when you use it, we know that I now is 3, right? I3 is 2 over 2, n is equals to 4. So we have 1, 2, 3, 4, 4n. How to find the n? Also stated in the previous slide. Okay, you can find the equation. So we have 4 here, and based from this 4, we can count the h. Okay, you can find the h also using the previous calculation, and we get 5 points, x0, x1, x2, x3, and x4. So they ask us f1 and f3, so we just find where is our x1 and where is our x3. So this is the value for your f1, this x1, and this is the value for your x3 that you need to insert into the equation. So you put the value x here for each of the f, and then you can find your answer for f1 and the answer for your f3. Then you can find your R31. For R32 and R33, we come back to the Richardson improvement. Okay, this is the formula from Richardson improvement. For R32, you just put the numbers you already get from the previous calculation, your R31 and R21, and then you will get your R32. And you can minus with your R31 and see whether it is bigger or not than your error. It is still bigger, so you proceed to find your R33. This is the formula for R33 based from the Richardson improvement. You put into the equation your R32 and R22, then you can find your R33. And then you can minus your R32, okay, and you can see whether it is less than your error. Okay, now you can see after you minus R33 and R32 results, you will get it is less than 0.0005. Now you can stop your calculation. This is how you write the solution. You can provide this statement where it say the solution is this is your fx equals to, this is the final one here that you calculated, the R3, right? R3 is equals to 2.8925. This is the answer. Then you also need to provide the table, okay, where you show each of the calculation, your I1, what is your H, what is your R11, and then your I2, what is your H, what is your R11, R21, R22, and then the last one here, I3, this is based from your calculation, okay. If you have 4, let's say 3, this one minus this one is still more than 0.0005, you can need to put number 4, okay. Let's say 0.05, let's say here, or 0.50, or this one is another number for 41, 42, 43, and 44 if you have not met the criteria for stopping based from the error. Okay, this is based from your answer in the question, based from the question. Okay, so for this question we calculate until R33, where we minus this, it is less than our error, so this will be our answer here. Okay, but you must make this table too.